Good morning, everybody. Thanks very much for joining us. Very pleased to be able to give you this introduction to Neo. I'm sure some of you will already know a little bit about it, so there'll be some presentation, but some repetition. But thanks very much for your interest, and I hope you will ask some questions. So we're going to get going just by really putting together some of the background for how it is that Neo4j is such a timely product. So first of all, I should say Neo4j is the creator of Neo4j. So Neo4j used to be, until about a week ago, called Neo Technology. We've changed the name of the company in order to make it clearer that we're really just doing one thing. We're only interested in one thing, and that reflects our core belief. We're only doing a graph database as our single product. Why do we do it? Because we want to give people the opportunity of leveraging connections in real time to create value for their businesses. What we're doing is expressing our core belief in a software product, and our core belief is that connections are as important as data. And that's something that's yielded great value, not just for our customers, but in the world that you and I experience all the time. And there are some good illustrations of that in companies that have really changed the world in the last 15 years. First among those is Google. Google is using connected data in the form of the PageRank algorithm to become one of the preeminent companies of the 21st century and having a big impact on all our lives. But they're not alone in that. Facebook likewise uses a graph to provide value to their users by providing the connections between people. Twitter is based on a graph, LinkedIn is based on a graph, and Amazon recommendations and catalogs and logistics are based on graph. So these are extraordinary examples of the way the world has been changed within recent memory based on using graph technology. So as processes get more and more digitized and as they get more and more interconnected, we're seeing what we identify as the emergence of the connected enterprise. So let's look at what an enterprise might look like. So here we have a company, and within that company, traditionally there are lines of business supported by silos. So there are silos for sales, silos for manufacturing, silos for supply chain, and so on. And that's just the beginning. Of course, even beyond those, there's greater and greater depth as we're looking further and further into the organization. We see there are innumerable different aspects to any even medium-sized, never mind large organization. So many of these aspects you're looking at the screen are themselves enormous and detailed, way beyond the ability of most systems to deal with them. And this is what we mean by the connected enterprise. We mean being able to span all of this and provide information about the interconnections between all of the different elements of this and finding the value in those interconnections. So if we think about an enterprise that's using normal approach to IT with ERP and CRM based silos, they're not really able to exploit the connections in their data. Even within the silos, they have difficulty necessarily understanding the connections between data items, but certainly across silos, it's almost impossible to produce what we call actionable insights by exploiting the connections between data items. So what sort of things are we talking about? So there are numerous use cases that people find are well supported by graph databases and by Neo4j. So we'll talk about some of these in a bit more detail as we go through, but for example, Walmart are using Neo4j for real-time recommendations. Some of the world's largest money transfer companies are using Neo4j for fraud detection, and some of the world's largest computer manufacturers or network manufacturers are embedding Neo4j in their equipment to provide network management and diagnostics. So what we're doing here is spanning those silos, but we're also able to start with a manageable starting point that pulls data from just one part of the business or from numerous parts of the business. And what we find is that the more you include, the more value. Now, you might be saying, okay, this is all very interesting, but why do I need a special database to facilitate this? And the first thing is that relational databases find it very hard to deal with queries that touch a lot of data. And a typical query can touch thousands or millions of data items, and that begins to slow down. And one of the remarkable things about graph databases like Neo4j is that their performance is invariant as the database gets larger. So it doesn't matter if you're talking about 100,000 records or 10 billion records, Neo4j will be giving effectively the same level of performance. And I'll show you a little bit about that in a second. The other thing that people find very hard to deal with is that as new connections are built into the database, you can't anticipate what the paths are. You need to have a database that can find paths in real time as they're connected. So if you have two people who are connected by having living at the same address, if a third person moves to that address, you might want to be able to use that connection, the fact that they've moved to that new address, to establish a connection with the original two people. And that's a very dynamic change in a path that it's very hard to deal with using traditional databases. And as I was saying before, one of the great things about a graph database is that regardless of the amount of data, you'll get consistent response times. So we see Neo4j often being used in real-time contexts, if you like, between a web request and a web response, to provide millisecond responses to queries that might be hitting large databases and inevitably are hitting growing databases. And we want to avoid the phenomenon which is so common, whereas databases get bigger, they get slower. And that's part of being able to run queries with consistent results. So if we look at Neo4j, it gives you a certain number of advantages. Part of that is based on the architecture of the database. It's what we call an enterprise-grade native graph database. It lets you store and query data relationships, to traverse those in real time, but also to evolve the graph, to add and connect new data on the fly. Now, looking at it a bit more deeply, it's designed and built to give you extremely high performance, to give you transactional integrity in the form of ASCII compliance. Compared to any other database, your developers or yourself, if you're a developer, will find it's extremely agile and extremely easy to build functionality quickly. And finally, it's very efficient in terms of hardware. And I think a lot of people have moved applications to the cloud and suddenly find themselves being a little bit surprised at how expensive their Amazon or Azure bills are if they're running large workloads in the cloud. And hardware efficiency is no less important now than it was 10 years ago. So let's drill down on some of these advantages in more detail. The first is what we call index-free adjacency. So Neo is unique, or graph databases are unique, in that we connect the data in the database as we store it, which means that we don't have to connect it when we're reading it. So we don't have to do the join operations that take so much processing power when you're traversing lots of tables, when you retrieve data, because we've written the connections directly into the database. So this is a huge advantage. It's called index-free adjacency, and basically means that you're not doing join operations during information retrieval. We do a little bit more work when we're writing the data to start with, to establish the connections, but the payback is enormous whenever you're reading data. And of course, even when you're writing data, you always have to read data before you can write it in order to write the right data item. So that's the first advantage, index-free adjacency. The next thing is that it's what we call a native graph database. So just going back a little to the origins of Neo4j, Neo4j came out of a failed project that the founders of Neo4j were involved in the early part of the 2000s, when they tried to implement a CRM system on top of a MySQL database, and they realized that the CRM system was heavily driven by the relationships between people in the company, and that they were really building, when they looked at what they built, they realized they'd built a graph database running on top of a MySQL database. And then they realized that there was a kind of, it's like putting a jet engine into a motor car. You don't get the best advantage unless you're engineering it all the way down. And the graph model on the top and the relational model underneath just didn't work well together. And it was in their frustration at this failure to deliver a good product that they decided that they would write a from the top to the bottom native graph database, which means that we control everything about the database, including the direct storage on disk. You'll find other people implementing graphs on lots of other data models, but Neo4j is able always to beat those because of this native advantage. This together with the index-free adjacency means we can get extreme performance, and we can read literally millions and millions of records per second just on commodity hardware, indeed on this laptop. And we've engineered more graph native characteristics into it to ensure that you get that complete, consistent performance and very high performance. And the minutes to milliseconds is a quote from one of our customers at eBay, talking about how long it took him to run queries on his previous environment compared to running it on Neo4j. So we've got a great advantage from performance thanks to the index-free adjacency, and we've got a great advantage in consistency. Because we're a proper database, we give ACID transactions. So if you write something, you can write a transaction. If it doesn't complete, it rolls back, and you're always given a consistent set of data. Okay, so looking at that performance in a bit more detail, this is some testing that we did, and I'm going to introduce you to a little bit of Cypher. So Cypher is the query language that Neo4j uses, and if we look at that Cypher there, we can see a set of statements, a match statement, and then a where statement, and just a return statement. Look at the match in detail. What we've done there is what we call a bit of ASCII Art. What we're doing is modeling a graph. So if you look at it, you'll see there are some round brackets. Those represent the nodes in the database, and there are some arrows, and those represent the relationships. And where the arrows have got names inside them, such as the bought, that's saying select the bought relationship among all the relationships that might exist between this node. So what we're doing there is saying we're matching you using a bought relationship with something. We don't mind what that something is. And then we're saying match somebody else through the bought relationship with that same something. And then we're saying let's find something else that someone else bought and recommend that as something that you might want to consider buying as well. So this is a pretty naive recommendation. Just because somebody bought something, you might want to buy it as well, but it gives you a taste for what the ASCII Art match looks like, and the difference between the expression using Neo4j cipher language and the equivalent in SQL. In SQL, typically within your syntax, you have to deal with complexities like joins and keys, which are really structural information which are irrelevant to the problem. Within Neo, you don't have to do that. You're just dealing with real meaningful concepts, because the graph takes care of all of the structural and architectural information. And doing this type of query, you can easily, just on my little MacBook, get millions and millions of hops per second, of reads per second, and because it executes in parallel, if you add more cores, you can get into the high tens of millions just on a single server. So that's drilling down on the performance advantage. Now we'll look at a different aspect. We'll look at the modeling advantage. So this is one of the things that people find most delightful, most pleasurable about working with Neo4j. The model is the way in which you model and translate the conceptual model into a computer program is so much more rewarding and so much more direct than it can be using a relational database or other technology. And that's because we have this idea that what you sketch on the whiteboard at a conceptual level becomes the physical model. So what we're looking at here is a whiteboard sketch, and then that becomes directly the physical model. And if we look at this in a bit more detail, what we've got here is two companies, ACME and Jupiter, and they're related because a member of staff in ACME has a contract with Jupiter. So it looks like the guy way at the bottom takes a phone from Jupiter. So this is an extremely common situation, but something that you'd be terrified to try and model in a relational database, because we're looking here at a phone contract, but it could be any sort of connection between any sort of entities, and Neo4j can handle that without any difficulty, just as easily as you can draw it on a whiteboard. So what we get here is something that's very easily understood, it's easy to evolve, and one of the most important points is it enables easy communication between the business and the IT. There's no concept of a DBA who's denormalizing the data structures in order to get high performance, which makes the data harder to understand on disk or imposes restrictions on how the data can evolve. None of that is necessary. The Neo4j database is super normalized. There's never any need to duplicate data. There's never any need to roll tables into each other for performance reasons. It remains as clear on the database as it was when it was being drawn on a whiteboard. Okay, so the final aspect to draw your attention to is the query language. So we looked a little bit at SQL in a previous, at Cipher in a previous slide. Now we'll look at it just to see how much difference it makes to you. So first of all, on the right here, we've got a typical SQL query, which is trying to find something you'd think was pretty straightforward. So find all the direct reports and how many people they manage up to 3 levels down. So this is just a fairly straightforward HR query that happens every day. And you can see that even those who are SQL experts will be struggling to understand this statement, and it'll take half an hour, a couple of hours before you can understand it with enough confidence to debug it or to make any changes. The exact equivalent functionality in Cypher is 5 lines. You know, I don't know how many lines there are on the right, but on the left, the Cypher query is extremely simple. And if we look at that Cypher, what it's saying is match. So that's the same match clause we saw before, and where, and then just the return, exactly the same as before. And this time the match clause is saying match a variable, which we'll call a boss, down to 3 levels, down to a subordinate, match through that subordinate 3 levels down to their reports, and just return the names of the subordinates and the number of people that report to the subordinate. Couldn't be easier. And you can anybody who's looked at Cypher will be able to understand that immediately and be able to fix it or change it equally quickly. So that's a massive productivity advantage and a maintainability advantage. So just summarizing on Neo4j, it's a native graph database which gives you massive performance advantages. It's got that wonderful whiteboard-friendly nature, which means that the modeling pain in the backside that's associated with a relational database where you're always making compromises and making decisions which will restrict your future flexibility. None of that's a problem when you're using a graph database. But it is an ASCII database, so compared to many of the other NoSQL databases that you might come across, this is suitable for your operational data. This is suitable for your real business operations. It understands transactions. It understands security. We're introducing a phrase in there of causal consistency. Causal consistency is a extremely important part of any high volume database, and what that means is that you can read your own writes. So there are updates happening all the time in real time, so it's very important that if you need to, you can force it to make sure that if you read some data, that it's always consistent with the data that's previously been written. So adding to that, we've looked at Cypher, looking at the list on the right. We've looked at Cypher as an extremely expressive and powerful query language. We've looked at causal clustering a bit. That also gives us what we call data center readiness. So it's designed to operate in distributed data centers and to maintain consistency in multiple data centers, and also to provide replicas for cache reading for remote access where speed is very important. I won't go into any more, but it's got great facilities for importing data, so you can import directly into the database without needing to go through a client. And finally, it's got language support for Java, JavaScript, Python, and .NET out of the box, and for every other language that you can imagine via bindings that we've written or our community has written. So looking at Neo4j, we've got well over 200 customers, close to 300 customers now, and their names that you know. So Walmart, as I've mentioned, is using it for recommendations. eBay is using it for logistics. In fact, for providing the eBay Now real-time delivery service. LinkedIn is using it, although they're not using it for the main LinkedIn that I use most days. They're using it for a very fast-growing and important market, LinkedIn, in China, where they've built a gamified interface in order to use social networking to attract university graduates who are providing the first community in a much more competitive space than in the West, where LinkedIn already own the business. In China, they're not in that strong position, so they have to compete, and the best way to compete is get people when they're leaving university, and they've had to develop a special graph-based social networking gamified interface to do that. So what we're looking at Telenor, which is the biggest telco in the Nordics, I think the 6th biggest telco in the world. What they've done is use Neo4j for identity and access management, and indeed made it possible for self-service management for corporate customers. So if you buy Telenor for your corporation, one of your staff can become the administrator of the way in which Telenor is made available to your staff members, and they use Neo4j for doing that. And finally, at Adidas, Neo4j is prevalent at the front end, so it's extremely real time, providing all sorts of personalization facilities. So we just drill down a couple more customers. The one I want to focus on here is Marriott. So I mentioned before that Neo4j gives outstanding efficiency of hardware. Now, part of that is because it's totally normalized, so there's no need to replicate data all over the place, which you often find it for efficiency purposes. But part of it is also just because of that the speed, which means you need less hardware to get the same results. And if you look at the second bullet under Marriott, they said they could get 10 times the transactions on half as much hardware as with their previous system. And this is a heavy system used for real-time pricing calculations. So the moment Beyonce announces that she's going to be playing in Manchester, hotel prices start to move instantly, and Marriott needs to be aware of that in real time in an automated way. And they use Neo4j for calculating the room rates based on real-time demand, which is a very intense process that has great knock-on effects to neighboring cities and neighboring hotels, etc. Looking at the Fortune 500 retailer, that's one of the big name or the biggest name web properties in the US, not Amazon, I should say, where on Cyber Monday last year we did 35 million transactions with a query being returned in less than 4 milliseconds. And the system that this replaced was the IBM WebSphere e-commerce server, and the reason that the retailer came to Neo was because they needed real-time recommendations, again to be sensitive to real-time changes in demand, perhaps responding to a TV ad or something like that, but also to real-time availabilities, so they don't want to be giving special offers on out-of-stock items or on to fail to reflect on the website promotions that are being created in real time. So that's absolutely one of the biggest properties in the US, and delivering massive performance in a enterprise critical function. Looking over to the right, real-time package routing. That's one of the largest postal services in Europe, and we were pleased to be able to have a headline which was that Neo4j saves Christmas, because we provided the routing facility that allows real-time routing of packages within this organization, so they could respond to problems on transport links, flight delays or road closures, and route their parcels in the optimal way to make sure that everything got through for Christmas. Going a bit further, some of our customers have been kind enough to say nice things about us. So looking on the left, eBay is actually a very large user of Neo4j in many different use cases, but this was the first. Volker Packer is an eBay engineer who introduced introduced Neo into eBay, and it was Volker who came up with the minutes to milliseconds quote. What they found, or what they told us afterwards, was that using Neo4j, their fastest delivery, so from depot to customer, was taking less time than the calculation to work out what the route should be for that delivery had been taking with their previous system. So, so as you can see, their fastest delivery is sort of from source to destination in 15 minutes. Their calculations were taking something like 15 minutes prior to that. Adidas, as I've said, is using Neo4j for highly personal customer experience, and they're one of these companies that's done that silo crossing activity with numerous product dimensions, numerous country and nationality dimensions, and numerous brand affiliations in the form of associations with sports stars, etc. LinkedIn China we've already talked about. They did a very comprehensive benchmark. There's actually a case study on our website explaining how they compared Neo with some of the other NoSQL databases. And the thing that they found was most rewarding, most decisive about Neo wasn't just that the transactions ran very fast and that read response is very fast, but that they could get a product to market very quickly because of that modeling simplicity, and because they knew that if they made a modeling decision, they could change it without enormous cost later on. So we've got a number of customers who are endorsing us, but it's not just the customers. We've got a good following among analysts. Forrester has named Neo4j as the most popular graph database. There's a website you may know of called DB Engines, which ranks all of the all the different databases in different categories. And Neo4j has been for several years massively the most widely adopted. So it's the most widely adopted, it's the most widely used, and it's got the largest community, and also we've got the most engineers and specialists working on building it. So it's the most popular graph database, and it's definitely got an enormous amount of momentum in the market at the moment. I mentioned before that it was an ASCII database, which means it's suitable for running your business, and that means that Gartner consider it to be an operational database comparable to SQL Server or Oracle or DB2, something that you can bet your life on. So it's not just an analytical tool, it's an operational database that you can use in real time to load transactions. And finally, the Bloor group has reflecting the information from Forrester and from DB Engines, but also by analyzing the product and the depth of the product and the breadth of the product and the momentum behind the delivery, see that we're the clear leader. We've got, as I say, nearly 300 customers, hundreds of thousands of users and developers, because of course the community development effort going on, as well as the on the payroll Neo engineers. We're powering hundreds of startups, and we have an enormous community. I think there are nearly 4,000 community members in London alone who come to our regular meetups. I was at a meetup last night which was presenting a thing called Neo4j, which was looking at human phenotype, which is genetic variations and mapping genetic variations onto symptoms and conditions and diseases. And there were people from the major players in this space, so from the Crick Institute and from the Genomics England. So we get a high level of engagement from our community who are intensely interested in the product and how it can be developed. And I'll talk to you in a second about how people are extending the Neo4j database. So it's an extremely easy to use tool. I certainly recommend that the first thing you do after this presentation, if you haven't done so, is to go to our website and download Neo4j. You'll find it extremely easy. And it's not just extremely easy for you to use on your laptop. It's extremely happy in a data center. It's extremely happy in a cloud deployment. So it's pre-installed in Amazon and Azure. It's very Docker friendly, and people use it with Mesos and Kubernetes and all the other tools, and you'll find a lot of documentation about that. So it's a very open platform, which people find very easy to accommodate in an enterprise environment. So to summarize, first of all, Neo4j is an ASCII database, so it's suitable for the most demanding real-time transaction-oriented workloads, as well as for analytic workloads. It's got that causal consistency, which means we can guarantee that you read your own writes. So Neo4j is designed for agility. So you can change the model rapidly, you can design things rapidly. There's no major graunching process exercise as you move from conceptual model to logical model to physical model, as you would with other tools. It's intuitive, easy to create, and easy to evolve. Performance, Neo4j, because of this index-free adjacency, is going to be massively faster, as eBay found, and massively more efficient. We looked at the Cipher compared to SQL statement for finding the number of reports that somebody would have in an HR hierarchy, and I hope that gave you a flavor for how productive Neo4j is and how efficient it is. But there are a couple of other interesting points here. It's very extensible, so that Cipher language can be extended by you if necessary, and there's an army of community developers who are creating additions to the procedural library all the time in the form of an artifact called APOC. APOC is our procedure and function library, so this is server-side code that provides helpers and integrations and pre-programmed analyses and all sorts of utilities to help you get there more quickly and to produce a more efficient system. And that is there are many people working on that. It's facilitated by one of the DevRel engineers, developer relations engineers in Germany, Michael Hunger, and anybody who's had anything to do with that has always been absolutely blown away by the productivity and quality and professionalism of that work. And finally, we talked about hardware efficiency. So remember that example at Marriott, where they were getting 10 times the volume with half the hardware. So I think we can say that we're providing an extremely efficient environment, which if you're in a cloud-hosted environment, a cloud-hosted deployment model, is really going to pay back over time in the form of less cost for instances.